Friction between moving parts is inevitable. It is the reason for mechanical wear in all mechanisms. The purpose of lubrication is to reduce friction to the maximum possible extent. Oils form a membrane intended to prevent metal surfaces from contacting each other. Ideally, metal parts slide on the cushion formed by the lubricant, but no lubricant can fully prevent friction surfaces from contacting each other. The RVS technology compound resolves this problem in an entirely new manner. Closer examination of gear wheels, bearings or cylinder surfaces opens up a whole new world. What seems to be a smooth steel surface is a mountain range with peaks and deep valleys. Under friction, these peaks collide and chip off. Metal wear particles are similar to gravel. Over time, they permeate the oil and end up in the magnetic plug or oil filter, a sign of intensive wear and possible damage. Tribology, the study of friction, wear and lubrication-related phenomena, distinguishes three types of friction: boundary, mixed and hydrodynamic frictions. Boundary lubrication is the friction between two surfaces in direct contact. In the initial stage, the friction is static. The peaks of the friction surfaces collide and chip off, resulting in an extensive release of thermal energy. This is accompanied by high friction and intensive wear. Cold starting an engine is a typical example of such circumstances. Cold starting can cause more wear than a 500-kilometer drive at normal engine operational temperatures. Fortunately, this stage does not last long. Soon, the oil spreads over the component surfaces in contact. Oils of higher quality tend to spread faster, which is one of the reasons why some oils protect friction surfaces against wear more efficiently than others. Mixed friction occurs between two surfaces in direct contact and partially from the lubricant's own hydrodynamic friction. The surfaces are separated by lubricant film thinner than the average peak height of the friction surfaces. With increased surface velocity, the lubricant's ability to keep them apart is improved by the influence of the hydrodynamic lifting force D, when the surface peaks are only in spasmodic contact, resulting in reduced friction and wear. Hydrodynamic friction occurs at even greater speeds, when the sliding surfaces are kept fully apart from each other by the lifting force D, as in the case of aquaplaning. In this case, the lubricant membrane is now at least twice as thick as the average roughness of the friction surfaces, and keeps the surfaces fully apart. This is the ideal situation. In practice, there is no wear, and friction is also minimal if the parts keep moving at sufficiently high relative speeds. When the speed drops, mixed friction once again prevails. This can be compared to water skiing. If the speed is high enough, the skier glides over the surface. Internal combustion engines have many parts moving at different speeds and in hugely different manners. For example, the crankshaft rotates twice as fast as the camshaft, and the pistons come to a full stop in the bottom and top positions. All in all, maintaining an oil film of sufficient thickness between all components of a complicated mechanism is impossible, even if the best oils are used. It is common knowledge that regardless of the oil used, machines wear out sooner or later. In principle, the solution is simple. If machine components are to glide over the oil film like skis over water, the friction surfaces must be as smooth as possible. However, such smoothing is an expensive procedure. The surfaces must be ground or even polished after turning or other machining. This means that additional work stages must be added to the manufacturing process, meaning that costs soar. Neither is the use of higher viscosity oils a good solution. These only increase the mechanical resistance and energy consumption of devices. RVS technology replaces polishing by producing a new triboceramic layer on the friction surfaces contacting the oil. The treatment is straightforward. The RVS compound is added to the oil while the mechanism is running. After a few hours, the treatment is complete. The RVS particles in the oil permeate the entire mechanism, but the triboceramic surface forms only on areas affected by friction and wear, where peaks are broken and the necessary heat generated. It is a chemical process sparked by frictional heat. The surfaces become much harder than most steel alloys. The new RVS compound produces a smooth surface by recognizing inherent material hardness and surface pressure. The smoother the friction surface, the greater the hydrodynamic forces. Even a thin oil film separates machine components and keeps them in a floating state. The layer created restores wear damage and optimizes the mutual traveling trajectories and tolerances to achieve the best possible values. The process is self-regulating and stops when the surface irregularities are fully covered by the ceramic material. With no colliding peaks, there is no heat for the reaction and the production of the new surface stops. Therefore, overcreation of a surface is not possible. The triboceramic surface forms only over worn areas where frictional heat is generated. RVS technology is smart. It covers heavily worn surfaces with a thicker layer than surfaces with less wear damage. No friction and wear means no new surface. RVS treatment is twofold. It restores worn components and improves surfaces subjected to friction. Even brand new components are never absolutely perfect. All manufactured parts have certain precision limits. RVS technology efficiently restores, adjusts and protects new and worn components and optimizes component sizes. RVS technology does not produce a temporary protective membrane on the surface treated. It integrates with the base metal and modifies the surface structure to become an entirely new surface. RVS technology is not an oil additive, even though it is added to the oil. Oil additives usually influence the properties of the oil, while the RVS compound has no effect on oil but modifies friction surfaces and integrates with them. After RVS treatment, the oil can be changed without fear of losing the compound. The results of RVS treatment last about 100,000 kilometers in the case of a vehicle or 2,500 operational hours.